The next thing is the closed interval method. So the closed interval method is particularly used to find absolute maximum and absolute minimum value. All right. So first step, determine critical numbers. We did a few examples related to this. Right? You know how to find it, determine the critical numbers. By definitions, the critical numbers are where you have f prime of x equal to 0 or where f prime of x is not differentiable. Then find the values of f at the critical numbers. Right? So we take the extra step after finding the critical numbers. Whatever you have for critical numbers, substitute back into the original functions to determine the output. But you do this on an open interval, not a closed interval. Right? We get to the closed interval part in a minute. Now find the values of f at the endpoint. Now the closed interval comes into play. So at the endpoint. So that means find f of a and f of b. So the largest value between 2 and 3, right? So 0.2 and 0.3 right here is an absolute maximum. And then of course the smallest value between 2 and 3 is an absolute minimum. All right, so let's look at some examples here. Let's find the absolute maximum and minimum values of the functions f of x equal to 12 plus 2x squared minus x to the fourth on the closed interval 0, 2. Right, the first step is to determine the critical numbers. So take the first derivative of the functions. You have, this is 4x minus 4x cubed. Set that equal to 0 and you solve for x. So 4x is the common factor in this case. Left with 1 minus x squared equal to 0, or 1 minus x times 1 plus x equal to 0. So the critical numbers are x equal to 0, x equal to 1, and x equal to negative 1. So that's the critical numbers. But you need to eliminate x equal to negative 1 because it's not in the interval of considerations, right? So we have to eliminate x equal to negative 1 because negative 1 is not in the closed interval 0, 2. Right, so you just need to have to consider 2 points. So the first point is x equal to 0, and the second point is x equal to positive 1. What is f of 0 equal to? You substitute back into the original functions, right? You have 12 plus 2 times 0 squared minus 0 to the fourth. You have 12. What is f of 1? 12 plus 2 times 1 squared minus 1 to the fourth. You get 13, right? Those are our critical points. Now look at the endpoints. The endpoint, you already have 0. The other endpoint is 2. So what is f2 equal to? This should be 4. Now you just make the comparisons for the absolute maximum and absolute minimum. Right? So the last point is absolute maximum is equal to 13 at x equal to 1. Right? When you consider a maximum or minimum value, that should be the output. So the output in this case is 13. So that's why I say that the absolute maximum is 13 at x equal to 1. And absolute minimum is equal to 4 at x equal to 2.